So my topic today is about unveiling the ARM confidential computing architecture on software stack. And my main focus here is really regarding with the container technology. So yeah, so for kata containers and confidential container support on ARM. Yeah. And just to generally introduce myself, I'm Zhao from Linaro. I'm the senior tech lead of the Linaro data center group. So currently, I have been evolving in the ARM ecosystem for more than 10 years. And previously, I'm working on the OpenStack on ARM, which is very interesting. Is that this project is under the Open Infra Foundation. And I've been there for, I also doing some presentations in several years before, just around the 2016 or 2017. And at that time, when I introduced myself and introduced my talk, I will always told the audience that, we are doing the OpenStack deployment in the ARM server. We have ARM servers. We are not doing things on the Raspberry Pi or other dev board. So because at that time, ARM is just a newcomer for the enterprise market. And as we can see, it has been booming during the last several years. So also, this is my second time at Denver. So, and I just chose some pictures here, very interesting pictures I take before in 2017. So, and there is one special experience for me is that the second picture here, in the second picture, it is a lake. This lake is in the Mountain Evans, which is one of the two mountains you can drive into the top. It's around 4,000 meters high, and you can drive it nearly less than 1 hour, so which makes you feel very extremely altitude sickness, so which makes me remember it very well. So this is my first time's experience. So, and it's good to see that this time we are taking the conference in the convention centers and in downtown. So Okay, here is my agenda today. So we have I will first introduce the generally development status for ARM CCA software stack, including the kernel and the firmware support. This is the first part. On top of that, I will introduce more information for kata containers development status now we have for ARM platform. And the last part here is for the confidential containers and also the remote attestation work we have done recently. Okay, first one, so the CCA software stack general information. So for talking about CCA, so it is not include only about the hardware. So this is a hardware bonding with the software solutions on top of the RME extension. So it is not only including the kernel firmware, but also with more tools in the container level for remote attestations, a hypervisor or something like that. And here is a general concept or architectures we have here for CCA. We introduce a realm support apart from the non-secure world, which is the normal world, and the other part is the secure world. And there are a bunch of the interface specification has been introduced. The IHI-ISI interface, they are used for the communication between the realm with IMM firmware or the normal world KVM2s or Qemu. And also the RMI interface, which is taking charge of the interface between the hypervisor in normal world and the realm in the secure world. So, and also ARM has introduced a new interface called Fermi, which is a firmware interface and just defined recently, and there is currently no spec, but they commit that they will have a spec quite soon. So regarding with the CCA 1.0, So the CCA history is just started at 2021. And after that, there are a bunch of the software development has been introduced. So from the firmware to kernel to hypervisor. So what we have today is we have our open to box softwares currently we have. Yeah. So we can, the CCA spec has been finally released in September 2024. And the firmware now is totally upstreamed with the TFA 2.20 and the IMM 0.6. And also, we do have some new advanced features here for IMM, which is maintained out of tree. It's in the Linaro repo I listed here. Yeah. The kernel support here, this is generally two parts for the guest support. The V7 version of guest support are just merged in the after the Christmas, yeah, this year. And also for host support, mainly regarding with the KVM. This one has addressed a lot of attentions in the Linux Coco and the Linux ARM mailing list. And in this May, they have just posted the V9 version. So this would be potential expectation to merge this year, and probably will be accelerate because we actually got a lot of requests to see that please, yeah, make it in upstream as soon as possible, because so there are a lot of requests and interested here. So the KVM2s are also hosted in the CC branch, and this one is also not merged depending on the KVM support. Yeah. So for firmware, the EDK2 is already listed in, is already merging in the EDK2 staging repo already. So there are two remaining things which is currently not finished. Is the first one about the DMA, and the other one is about the huge page support. So both of those two things introduce more complicated, and the authors choose to sublet these features to submit after the main features merge first. Yeah, to reduce the complicate. So that is for currently we have for the 1.0 spike. And next here is more coming with the new features with CC 1.1. So the 1.1 is, we know, so with the 1.0, this is not a production ready feature deployment for CCA because it lack of some important features, which is listed in 1.1. The first one, the memory encryption context, which will enhance the different realm. We will have the different encryption keys. And this one has already been posted this year. Yeah. And it will be upstreaming after the CCA KVM support has been merged. The other feature here is planes. Yeah, planes. The concept of planes is introduce some new level in the realm, which is the plane 0. This will be served as more or less like a hypervisors, and also there are plane N, which can running the normal working the normal working process. Yeah, they have been introduced some changes in either the IMM and hypervisor. So the plane support here is we have just doing the IMM support first. Yeah. So the plain user cases here I want to mention here is about this was requested by something like VTPM because also Windows need a VTPM to running in the plane in plane 0. So that one is a special use cases for plane. Yeah. The third one, and this is I should say the most important one for this is a device assignment. Yeah. So today, every people say about confidential computing, and we know that we cannot avoid anything about GPU. So this one is address the issue for GPU attestation. it's good to know that even though ARM is starting a little late here, right? We are starting at 2021 for the computational computing spike. But for device assignment, we are not running very slow because each of the hardware vendors are also work in progress for this part. Yeah. So the DA support here is we are doing something already for the initial KVM support, the initial KVM tools, and also the firmware support. So and also we have doing our development tools called shrink wrap for developers to easy deployment on the FVP, the faster virtual platform. And also the spec is already being proposed by the 1.1 alpha release, which including the plans, which including the device assignment support. Yeah, so this is for plans status. And the other three, yeah, so the live firmware activations, the boot sync, and the flexible memory management. So those are just proposed and will be working in progress. So yeah. This is a CC 1.1 currently status. I should see, so this is still working in progress, yeah. And needs some more times to upstream. Yeah, so the developer getting started. Yeah, so we know we don't have any hardware support for ARM CCA currently. So if you want to do something, yeah, we offer generally two methods of the reproduced environment. The first one is proposed by Linaro. So we have writing a detailed documentation and also a handy tools for the developer to using ways to build generally the Qemu host for running as a CCA host. And also we build a bunch of the file systems, the firmware or EDK tool, and then we offer the Qemu serving as a VMM. So this is a pure Qemu and Qemu on top of Qemu. Yeah. So this is the first part, and the other parts are proposed by ARM. Yeah. So this is the shrink wrap tools which suppose CCA configurations. So and this one is based on the ARM FVP, which is not only the AES FVP but also the Nearverse v3. So the FVP will be emulated more. Has a more feature support here, especially for the FVP are already support the device assignment hardware. So emulated the development equipment hardware. So if you're doing something about DA, you can using the FVP support with the Nearverse v3. Yeah. And also there are some articles we recorded either in ARM landing pass or in the Linaro collaboration page. You can get information here, yeah. So for the development, it is very handy. So just one or two command, you can build the total environment and launch the realm. The last part, yeah. So it's here. It's about CCA demo. So this part is using. We have defined our CCA end-to-end solutions. This one is we either building the Qemu support and also including different parts of the things with remote attestation, and the first demo including to using the Verizon as we know this is a CCC's project to do the attestation service. Yeah, so this is the first demo, and the other one is we using Verizon to and also a handy tools to generate the DTB for the RIM. Yeah, so this one is about the measurement support for the RIM. So more information here. So we just have passed the Linaro Connect in this May, and there are a bunch of talks about with ARM CCA. So if you have more interest, you can redirect it to this link. This will including all information probably as you want. Yeah. So, and this link already have all video and slides. All right, we came to the second part. Yeah, the kata container support on ARM. So first, I want to say why we want to do the kata containers here, because we know that for different hardware, and we are using currently, and we're using the confidential computing technology, I mean TE here. So currently the only way we are using, or the most efficiency we are using, we should to integrate it with the Kubernetes environment. So a kernel container is one of the components we cannot avoid to make it compatible with a Kubernetes environment. Yeah. So, and basically, confidential container is based on the kata container technology. So first, I want to see that what is the currently status on kata on ARM64. Yeah. So kata container was first launched probably in 2017, and in 2018, we have supported the ARM. And in the version after 3.20, we have the kata container built-in support. And so from the community perspective, they can release ARM tables. Yeah. So, and this is based on Qemu support. And for the kata container cloud hypervisor support, this has been started at 3.3.0. There are also, we have adding some CI coverage here for either the building CIs for the total tables regarding with kata and its corresponding different components. Because we know kata is a middleware, it has also needed the guest kernel, guest firmware, the kata runtime, and also you need to configure the container Ds, the CNIs, blah, blah, something like that. So it has a bunch of different components, right? So, and those different components will be automatically built into a table. And then in the CI job, it will using kata-deploy to deploy the kata's dependencies. So, and running the test. So we have just, the CI has been some backforth. There are some migrations and the problems we have fixed. And currently there are 2 jobs regarding with kata. All of them are the Qemu backend. So the first one here is about the CRI containerd job, which is just adding 2 weeks before. Yeah. So the other one is Kubernetes test with kata. So, and currently limitations here for kata. Yeah, this is the vCPU hot block support. And from Kubernetes perspective, the problem is the pod quota site has an issue. And I can introduce why the vCPU hot block support does not have problem. So here is the status for the vCPU hot block. From x86 side, we probably know that the vCPU hot block probably introduced several years before, but hello, yeah, good, I'm back. So, yeah, so the kernel support for vCPU hot plug here is starting at 6.11 last year. And the problem here for Qemu is there are 2 bunches of support. The first one in Qemu is architecture agnostic. It's a architecture neutral support. This one has been already merged. And the other one here is about the vCPU hot plug for ARM v8. This one is still work in progress. So we should block kata support for several long time. So, but this has been verified and worked, but we're still waiting for this support. This is the main problem here. The other thing here is about memory hot plug. I want to introduce more, yeah. So the background here is the ACPI PCI device hot plug is also not supported for Qemu vert. And also, the PCI standard hot plug controller, which we know the SHPC, due to the low performance and the design problem, so this one has been disabled in 2021 in kata. So we have only introduced the support for memory hot plug via the volatile memory currently. So, and after we introduced this thing, we found, and the NVDIMM support has been also introduced, and we hit another regression. And this one has been recently fixed. So, for enabling the virtual memory, you need to specify the firmware, the ETK2 support. So you cannot do this with the direct kernel boot. So, and this is generally, currently we can using the virtual memory. And in the future, I can see, so the ACPI PCI hot plug native way is already proposed a patch by Red Hat, and also this is planned to be landed in Qemu 10.1 version, which will be ready quite soon. Yeah. Okay, so apart from the Qemu vert, we are also done something with the Qemu SBSA reference. So the Qemu SBSA reference is a platform Qemu model which emulated the more complicated board-related features other than the Qemu vert. So that will be much easier for some hardware designers to do some testings. For example, to do the ARM system ready testing in the Qemu SBSA. So in this part, we have supporting the GPT large mapping support, which will enlarge the memory. So for the Qemu vert emulation, we can currently just using the 3 GB memory for the serving as a host to development. Yeah. So apart from that, we're also doing some distro support here for the build root, Debian, and Ubuntu for serving as a host, the host file system. Yeah. So regarding with the CCA support, which would be quite straightforward, the kata has the kata runtime, and we introduce Golang and Rust support for CCA, which is very straightforward. And also on top of that, there are some components which will be packaging to the kata root file system. We call that a attestation agent. This one is proposed by Cocoa community. Yeah. So this part also need to including the CCA support, which has been already supported. Yeah. So from deployment part, we are using the kata-deploy to deploy a total cluster, which makes the deploy easier. So we have also supported the building different components, the workflow here to support kata CCA. So the supporting things here is, unfortunately, this part is still not be merged on the upstream. Part of the limitation here is about the kernel KVM support is still not is still not merged. So what we are using is based on our Qemu, it's based on our out-of-tree version. So the current function we realize is we support the Qemu Golang backend, Qemu with Golang runtime, and also supporting the firmware boot, the UEFI boot, and the direct kernel boot. We can support the kata-deploy to automatically build the kata-related components regarding with the CCA. And also, we're doing the compatibility test with the pure CCA v8 version. So for development, we've also writing our script to building the CCA, the kata equability CCA host, because the host for running kata is a little different with the things for just running a CCA ROM, because kata need more kernel configurations, which is different, and also it needs some, usually it need a root file system. Currently here we are using Ubuntu. So, and we have also writing a development guide for running kata and Cocoa in computational computing with CCA. Okay, last part here, so for Cocoa support and also the remote attestation here, which would be more interesting probably. So here is the general architecture for the Cocoa, the configuration containers. We can treat it in the attestation area. We can easily divide the 3 parts of the components. The first one in the here in your left here, right? It is attestation verifier, which is in Cocoa side it is a Trustee. Previously it is Cocoa AS, but now it has been changed name to Trustee. And the Trustee will serve as a maybe an agent, it will either using different verifier. We can using the Verizon as a third-party verifier, or it can also support to do the local verification here. Maybe using, for Intel, you can use the Intel decap library to do the local verification. And we also offer we call it the Trustee CCA token to do the local verifications. Yeah. So in the middle part is a relying party. Yeah. So here is there is running a key-broker service. And in the right part, in your left part here, there is a tester. The tester here will gather in the attestation informations. So for CCA, we also add support for in the realm to get the attestation tokens. But this is a very standard interface using the Linux TSM. So that will be very easy. Yeah. So after we got the token, we will deliver to key-broker. Yeah, I mean, in the relying party, and the relying party will send this evidence to the attestation verifier, and then get the information attestation back. Yeah. So here we can see. So for the CCA support, what we should do here is the attestation agent part, we need to support CCA, and also the attestation verifier part, we need to aid in the support. So for both of those two, yeah. So we have two integrations with Coco. The first one is a Verizon integration. This will be offload the attestation verification request to the Verizon third-party service. So in that part, it will be serving. We need to provision any trusted voucher informations to Verizon first, and doing the attestation, offload all the things to Verizon and get the attestation results. Either we can also provision some information locally, and using the local verification libraries for we should get provision the reference values locally, and also provision the trusted voucher information locally, and doing the attestation. So so we can doing that either way, yeah, right. So and for the upstream part, we can see all these things has been upstreamed. In the first part here is Trustee support, which has been already merged with different attestation verifier, and also in the guest components in the attester support, this has been already supported the CCA support via the TSM. Yeah, so in next part is about the EAR. Yeah, we can see the total attestation. We cannot get rid of the Coco AS support, as I mentioned here in the in here, right? And we can see we should be, if we're doing some standardization work, we can just get rid of this part, so that we have co-work with the Coco upstream to introduce the EAR, which after we adopt of the EAR, so the trustee key broker service can directly consult the Verizon remotely to get the attestation result without any Coco AS, right? So, and also Verizon has an overlap with Coco here is about the reference value provider. So the reference value appraisal has already been done by the Verizon, so they don't need to be doing twice in the reference value providers part. So after we adopt with the EAR, we can get rid of this part. Yeah. Okay, so this is the EAR support, and we can think about either way. The other way, for the local verification, we have currently this is just a POC for the endorsement API. Yeah. So for endorsement here is that we know from the local verification part, we need to provision the trusted voucher informations and also the reference value informations locally, right? But this is not very handy or suitable for production level. So this is just a POC. So in order to get this production level and reliability, so we are currently working on the standardization for the endorsement API, which I mentioned here. So we will have our third-party service to maintaining the trusted ultra informations provisioned by maybe the hardware information, the hardware vendors, and also the software supply chain vendors. And also locally, there will be running a cache service, and the cache service will subscript any update from the remote attestation from the remote endorsement API server to get any information update. And when we're doing the local verification, we can just get information from the local cache service to get the trusted ultra and also the reference values and to do the local appraisal. So in that way, we can so get a rate of either the long-term HTTP request or something like that. Yeah. So in that way, we can use a Rust CSA token to doing the things locally. Yeah. So yeah, this is a feature about the Cocoa Trustee. Probably with the endorsement API here is that we are using the local verification part to have our and we have our reason to running probably in an endorsement API service. And also the local cache will store the reference value and the trusted ultra. So after that, when we're doing the local verification, we can just talk to the local cache and doing the verification, which makes the things more easier. Yeah. Okay, so I guess that is my last slides. Yeah. Okay. So if you have any questions or information regarding with CCA, so welcome to, please.
So, after you, go. I have too many questions. So, ARM obviously has a licensee model.
Yeah.
So, where does the licensee fit? Is that in the endorsement model? Can you show us where? How? Do you see what I mean?
Sorry, you mean the?
Where does the licensee fit in the attestation model? Where are they providing their input? So
they need to, okay, you mean the endorsement API, POC. Yeah. They need to provision the information to the endorsement server, and there will be a work in progress APIs to doing this.
Okay,
yeah. So
there's all this trusted firmware. What is that running on? Microcontrollers? Where
oh, you mean trusted firm TFA, right?
Yeah, TFA and the other one TF. So
okay.
They're both trusted firmware.
Let me see here. Oh.
TFA.
Okay. Yeah, TFA and TFA is running in the root in the root state. Yeah. So they are not running in another MCU. They are really running in the servers. Yes. And the IMM here is running in the realm world, but it is also.
So the reason it's called firmware is because it's not part of the operating system.
Yes, we treat it as a firmware. Yeah. Okay.
So you don't need any special hardware to do this besides the ARM CPU.
We probably need one for the root of trust. I see the RIC. Usually, ARM advice we're using another micro CPU as a secure trust.
Okay, so that's like a TPM or a secure element, or what do you call it in ARM?
Yeah. So here is a So but something like a TPM, but this is hardware. So yeah.
It's an IP block which you have to put in as part of your ARM silicon, right?
This should be separate with the server chip. This is another, usually a Cortex-M chip to do this one. Yeah,
okay, so it's a Cortex-M.
Usually, yeah. So. Okay.
I have a newbie question. What's the Intel equivalent of CCA?
TDX.
TDX, SCV, SMP. So, yeah. Okay. Bike.
Oh, no, not that.
That one?
Sorry, on. Stop. No, next one. Yes, flexible memory management. Could you tell us what that's going to do? Does it allow you to change the allocation of a realm at real time, or what is it, something different?
This one, I should see, this is like the memory the management between the realm and the, so the memory management between the realm. So, but yeah, actually, this is still work in progress, I should say, yeah. I need to take a deeper look and get an answer, yeah. Thank you.
Are realms like secure enclaves or no?
A realm is a trusted execution environment, like a TDX or an SGX or SMP T.
Okay, so
Yes, secure enclave here is, sorry. The secure word TA is a secure enclave. Just for example, the OPT.
okay.
Yeah, so
Enclave is a specific term used by SGX. These days we tend to use TEE, which encompasses VMs and combination VMs and.
Okay, so enclave is a bad word.
It is a bit, yeah.
Okay, got it. I had another question. Okay, so, all right, so, like, it's not SGX, right? Because this is ARM, and SGS was Intel. Does that,
Yeah.
so are there, like, special instructions in ARM to do this realm stuff? Or?
instructions. Yeah, we need the IME extension to support this after the ARMv 9.2.
Okay.
Yeah,
So,
so.
those are the
So that's why we currently don't have any hardware support.
Oh,
Yeah.
so there isn't any silicon that's...
Currently, they are still work in progress.
Okay.
And hopefully, maybe this year or next year, you can get one.
Announced the Monaco chip, which will have it in. I think there have been some other possibilities, but that's one which is.
Yeah, Fujitsu Monaco. Yeah, so regarding with the question for SGX, so in ARM world, we have the trust zone. So both of those two realizations share the same problem about using for APP developer, you need to do in the API to do the development. So which makes things a little harder, so yeah.
Software. We need those people.
Yeah, so from an infra perspective, so all the APP developers are your customers, so they don't want to change anything.